Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good day. Okay, my name is Mohd Firdaus Mohd Siam. I am a researcher from Malaysian Institute of Road Safety Research, MIROS. And topic of my presentation today is driver distraction measurement in real road traffic environments and instrumented vehicle study. Okay, next slide. Okay, the contents of my presentations today will cover the following topics, which are: number one is introductions, number two, motivation behind projects, next, the objectives of this project, methodology, results and discussions, and next is conclusions and recommendations. Okay, next slide. For introductions, one of the severe and rising menace to road safety is driver distractions. According to Rainey, 1994, a driver distraction can be defined as doing any task other than main task, which is driving, in which can divert driver attentions that can impair the driver performance. And many literatures discover that driver distraction is well known as a causal factor in at least a quarter of vehicle accidents, and these numbers could increase in the future due to the amplified usage of technologies such as mobile phones and navigation device. Okay, next slide. For motivation behind the project, in year 2018, about 6,284 fatalities were recorded due to road crashes, with an average of 17 people were killed every day. And human errors are the major contributing factor, which is about 90% of the road traffic accident. And also there is literatures mentioned that naturalistic driving studies have demonstrated that drivers have a tendency to spend a vast amount of driving time with a secondary task, which is about 23% of all crashes and near crashes were caused by distractions due to secondary tasks. Okay, next slide. There were studies conducted by MIROS. Number one is pertaining the objective to measure the response time of several secondary tasks, including texting usage while driving, that concluded that 97% difference of texting response time as compared to baseline tasks. And also there was a driving subject study conducted by MIROS also, that drivers were more distracted when dealing with more demanding tasks of using mobile phones, which is conversation tasks, as compared to a baseline. In addition, participants attended the worst in terms of stimuli and higher response time in traffic jam scenario as compared to other scenarios. And also there was a study, a self-reported survey pertaining mobile phone usage while driving in Klang Valley, has shown that 43.4% of drivers in Klang Valley use their mobile phone while driving, and 61.9% while stopping at red lights, and 53.6% use their mobile phones during traffic jam, according to Aini and Sharifah 2016. Okay, in Malaysia, there are no specific accident data, which is a type of fault related to distractions. Nearly related, which are the careless driving, dangerous driving, dangerous turning, dangerous overtaking, driving too close, careless at entrance or exit, negligent signaling, which is the total is about 74.81%, according to PDRM 2015. And also, according to PDRM, about 46,262 summonses of using mobile phones recorded, with average of 126 summonses per day. And according to MCMC in 2015, approximately 176.5 million phones sold in Malaysia, and the number of SMS sent was approximately 25.8 billion per year. and with the advancements of technologies, it is expected that will raise the driver distraction issue. Okay, next slide. Okay, one of the prominent tools to study the human factors related issue from road safety point of view is using an instrumented vehicle. Instrumented vehicle is a research tools used in a in a naturalistic study to understand the driver behavior and also to evaluate driver behaviors and performance. Instrumented vehicle is actually an alternative to the traditional methods such as self-reports, which was widely argued to have a limitation in studying driving behaviors, according to Boyce and Gell 2001. And also next, according to Young, Reagan and Hammer 2003, distraction response task or DRT is one of the methods for measuring driver distractions. The DRT method is a task in which participants respond to repeated stimuli presented within specific durations, and also detection performance measured in terms of response time represents the degree to which selective attention is affected by the tasks under evaluations. Okay, next slide. The objective of the project is to measure the driver distraction in terms of participants' response time and also hit rates for different road conditions and secondary tasks in real road conditions. Next slide. For the project methodology, for the participant, we use 16 participants, which equal number 8 females and 8 males, and each range from 25 to 45 years old, with mean of 31.75 years old, and all of them is actually all licensed drivers, and average driving distance about 21,300 km per year, and the mean of driver experience is about 12.12 years, and they took part in the study as volunteers. Okay, next slide. MIROS first instrumented car, or IC01, was used in the project purposely to acquire the data pertaining to driver behavior. And the instrumented car setup is categorized into 5 main components, which are audio and video system, data acquisition system or DAQ, power module, DRT, and also the secondary task device. For the DAQ or data acquisition system is actually is capable of acquiring analog, digitals, and counter type of signals from the instrumented car system. And also the signals of the instrumented car can be acquired. The signal of the instrumented car can be acquired are vehicle speeds, engine revolution per minute or RPM, horn activations, high beam, left and right blinker, and also brake, driver seat belt usage, steering angle, start axials, accelerometer, and also the functions of power module in the instrumented car is to supply stable electrical power to the DAQ. This is to ensure reliable operations of the DAQ during data collection process. The module consists of a battery isolator which perform as a one-way valve to ensure the DAQ battery can be recharged without draining the car battery. Okay, next slide. And for DRT or detection response task is one of the methods for measuring driver distractions, and the task is purposely for measuring the effects of the driving and secondary task demand on driver distraction attentions, in particular in the context of drivers and vehicle interface evaluations. And then the tactile DRT were used in the study. The stimuli were presented at temporary interval randomly and uniformly distributed. Also, the tactile stimulus was presented by using a small electrical vibrator that was placed on the driver's shoulder using a medical tape. and participant will respond by pressing a micro switch attached to the right index finger to the steering wheel. Okay, next slides. We use the auditory presentation verbal response delayed digit recall task, or NBAC, for the secondary task. It consists of auditory stimuli that the driver listens to and repeats the following the specific rules. Okay, the task involve oral and memory attentions that resembles actual driving activities, such as responding to mobile phones call and conversation with passengers. A pre-recorded voice was channeled through a set of speaker acting as the auditory stimuli, and the respondents were presented with two levels of difficulty of delayed digit recall task, which is an easy task, we call it as the 0 back, and hard task is a 1 back, levels for secondary cognitive workload. The protocols on training and the experimental administrations of the auditory presentation were adapted and adopted from Massachusetts Institute of Technology, or MIT, each lab. For 0 back tasks, the respondents were required to say out loud a number of randomly ordered auditory stimuli, which is single digits 0 to 9 as it were presented. And for 1 back task, the respondent were required to hold in memory each new numbers as it was presented and say it out loud with the number 1 positioned back in the presentation sequence. The experiment for secondary tasks were only conducted along expressway instead of curvy and ramp road segments, as we perceived high risk for participants to be involved in accidents. Okay, next slides. This is the video screenshots of the data collections. From the photos, we can see that participant is doing a secondary task and back, and also drivings. Okay, next slides. There are some guidelines and instructions that needed to be given to the participant before training and executing the actual task. Each participant required approximately 1.5 day, or equals to 11 hours, to perform all the procedures. And prior to the detailed briefing, participants were given an overview of the experiments, its expected durations, and the experiment procedure. And upon completion of all the experiment tasks, the participants were interviewed on their experience while doing their driving sessions at the specific room. Then the participants were thanked and given a token of appreciation for participating in the experiment. Okay, next slide. Okay, the experiment was conducted on 3 different roads, which are the expressway, off-ramp, and the curvy roads. And the expressway involved along Kajang State Highway from Sungai Ramal Toll Plaza to Petronas petrol stations, SKVE, and the distance travel was about 11.5 km and took about 10 minutes of driving period. Okay, next slide. For the off-ramp road, it involved the roads from a flyover at Petronas petrol station, SKVE, to a flyover after a third off-ramp, or E26, and the distance travel was about 2.9 km and took about 3 minutes of driving periods. Okay, next slide. Whereas for curvy road, it involved the road from Kampung Jendram Hile to Bandar Baru Salat Tinggi, or B48, and the distance travel was about 11 km and took about 10 minutes of driving periods. Okay, next slide. This is the photo of the training and also the data collection session using an instrumented car, the RT device, and also the secondary task. For results and discussion, the one-way ANOVA was used to compare the means of 3 categories of road types, which are expressway, off-ramp, and curvy roads, and secondary tasks, which is no task, 0 back task, and also 1 back task. All the statistical analysis were performed using a statistical package for social science, or SPSS. In this study, the 2 performance measures calculated at hit rate and response time. The definition of hits are the numbers of stimuli reply to within 200 and 2500 milliseconds from stimulus inception. The hit rate is defined as the number of hits divided by the total number of stimuli during a task given to the participants. And in the study, the hit rates for all tasks exceeded 90%, and there is no significant difference observed between all tasks, which are road segments and secondary tasks. This is aligned with the findings obtained from studies conducted by Transport Canada. Next slide. The response time, which is RT, on the other hand, is defined as the time from stimulus inceptions until the response from the micro switch is recorded. Analysis of the data showed that off-ramp recorded the highest mean of response time, followed by curvy roads and expressway, as shown in Figure 1. A slightly high standard errors were found for off-ramp and curvy, but still within acceptable values. Further analysis using ANOVA technique is indicated that at least one pair of mean response time between the road segment categories were significantly different, which is p-value is equals to 0.011. Subsequent post-hoc analysis, or LSD, which is LSD procedures, suggests that the mean response time between expressway and off-ramp and expressway and curvy road were significantly different. On the other hand, the mean response time between off-ramp and curvy road was not significantly different. This shows that the response time for off-ramp and curvy road were significantly longer than the expressway, which is also supported by a study conducted by Habluk, Burns, Tam, and Glasduri, 2012. Okay, the RT performance for secondary tasks, which is NBAC, was measured as well. Figure 2 shows that response time were longer for the more difficult and NBAC tasks, which is 1 back, followed by the easier versions, NBAC, which is 0 back and baseline. Analysis using the ANOVA test revealed that response time differed significantly across the 3 tasks, which is p-value less than 0.01. Although the standard errors for 0 back and 1 back were slightly higher than the baseline, the values were still within a acceptable range. Further post-hoc comparison using the LSD procedure indicated that the mean response time for baseline was significantly different than the 0 back and 1 back tasks. However, the mean response time for 0 back tasks did not significantly differ from the 1 back task. So overall, longer response time were observed for the more demanding and back tasks when compared with baseline driving. Okay, next slide. For the conclusion and recommendation, objective of the study were achieved, whereby to measure the driver distraction in terms of participant response time for different road conditions and secondary tasks in real road condition using instrumented vehicles. Overall, the result shows that response time generally increase as a function of road manipulations as well as exposure to a secondary task. The finding of this research indicate that in terms of road segment, longer response times were observed for the more demanding off-ramp and curvy road section when compared with the expressway. Furthermore, for the secondary task, the participant took longer durations to respond to the tactile stimulus, particularly for difficult and back tasks, which is 1 back. This study shows that doing secondary tasks while driving is considered as distracted activities that possibly raise the risk of crash. It is recommended that a driving simulator, which is less risk and under controlled environment, could be utilized for a future study and be able to simulate varieties of driving scenarios. I think that's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.